Good day, guys. You are welcome back to ID International Academy Mathematics class. Let's consider Law 3 under exponential equations. I call this one fractional index resolution. What do I mean? In a situation whereby you have a kind of fractional power, as you can see here, if x raised to power 3 over 2 is equal to 8, find x. What do you do? How do you approach this? So, at this level, what you do is try to express the number on the other side in index form and see what it looks like. After that, multiply the powers on both sides by the reciprocal of the power of the unknown. Have you captured what I've said? Multiply the powers on both sides by the reciprocal of the power of the unknown. That is how we resolve fractional index problem. This is what I mean. I rewrite it as x raised to power 3 over 2, which is equal to 2 raised to power 3. I write 8 in index form. Now, the instruction is to solve this. Multiply the powers on both sides by the reciprocal of the power of the unknown. The power of the unknown here is 3 over 2. The reciprocal of 3 over 2 is 2 over 3. It is that 2 over 3 you will use to multiply the powers on both sides. Thus, x raised to power 3 over 2 times 2 over 3, which is equal to 2 raised to power 3 times 2 over 3. That is what I'm saying. 3 we cut 3 here, 2 we cancel 2 there, having x raised to power 1, which is equal to 3 we cancel 3 here, we have 2 raised to power 2. Don't forget, x raised to power 1 is x. 2 raised to power 2 is 4. That is how we resolve fractional index when it comes as a problem. So, I don't count this as example, even though it's a good example. I only use it to illustrate the case of fractional index resolution. So let's move to the next example under this for perfect understanding. Example 3. Solve 3x equals 24 divided by x raised to power half. In this case, the easiest way is make your cross multiplication. If you cross multiply here, you have this over 1, x raised to power half times 3x. So that gives 3x times x raised to power half, which is equal to 24. What do you do next? Divide both sides by 3. You can see that 3 can go on both sides. So this will be 3x raised to power 1 times x raised to power half divided by 3 equals 24 divided by 3. 3 will take out of 3 here, but you have x raised to power 1 plus half. Remember the law of indices. X raised to power 1 times x raised to power half. Pick one of the common base, then the multiplication sign changes to addition. You use the addition to operate 1 and half together. 1 plus half equals 24 divided by 3. That gives us 8. So this is x raised to power 3 over 2 equals 8. Wow, what a coincidence. The point I used to illustrate the fractional index resolution case, that is what we get here back. And it is not intentional. Just a coincidence, good coincidence. So, we now resolve from here. X raised to power 3 over 2 equals 8. Then try to express it as 2 raised to power 3. Express 8 as 2 raised to power 3. To now have the final solution here, use the reciprocal of 3 over 2 to multiply powers on both sides. The reciprocal of the power of unknown will be used to multiply the powers on both sides. Power of unknown here is 3 over 2. Reciprocal of that 3 over 2 is 2 over 3. Use 2 over 3 to multiply powers on both sides. That is x raised to power 3 over 2 times 2 over 3, which is equal to 2 raised to power 3 times 2 over 3. So 3 we take out of 3, 2 cancels 2, we have x raised to power 1, which is equal to 2 raised to power 2. And x raised to power 1 is x, while 2 raised to power 2 is 4. Fantastic. I like this question. Just a coincidence, but I like it. It buttresses what we have been saying. So let's consider this example 4, which is a general example under exponential equation. When you see a question like this, you can simply cross multiply for easy write. 1 over 1. So cross multiply, you have 1 times 81 raised to power x, you have 81 raised to power x minus 1, which is equal to this jargon times 1. It gives you the same thing. 1 over 9 raised to power 1 minus x. So this is 3 raised to power 4 into x minus 1, which is equal to, you rewrite 1 over 9 as 3 raised to power minus 2. Can you recollect? Under law of negative index. Good. 3 raised to power minus 2 into 1 minus x. Remember this law, probably the first law we started with under laws of exponential equations. We have common base on different sides of the equation. Definitely the powers are also equal. So you write, therefore, 4x minus 4, I open the bracket, is equal to minus 2 plus 2x. I open the bracket as well. Minus 2 times 1 is minus 2. Minus 2 times minus x is positive 2x. So 4x minus 4 is a power on this side. Minus 2 plus 2x is a power on this other side, and the powers on both sides must be the same so far their bases are equal. So let's resolve this equation. We have 4x minus 2x equal minus 2 plus 4. So this is 2x is equal to positive 2. X is equal to 1 when you divide both sides by 2. Your answer is 1. X is equal to 1. That's the end of that. You can see how straightforward it could be. Let's consider the last example for today under this exponential equation 1. You know, I promised that we are still moving to 2, which is going to be the apex of it all. So, when you are given a question like this, how are you going to approach it? You write 3 raised to power 1 times 3 raised to power minus 2. Remember the law of negative index into x plus 2 equals, wherever you have 1 like this, and that one cannot, be dealt with in any other way. In the previous example, something was equated to 1, but through the cross multiplication, the 1 disappeared. So that one is by the way. But in this case, there is no way you can, manipulate the 1 other than this way I want to introduce to you now. Wherever you see 1 like this in indices, it simply means that something has been raised to power 0 to give us that 1. And that something must be the base in the operation. The base in the operation now, by inspection, is what? 3, 3, 3. That base must have been raised to power 0 to give us 1. So, that base raised to power 0 is the representative of that figure 1 in this case. So, applying the normal law of indices of multiplication here, this is 3 raised to power 1 plus negative 2x negative 4. I open the bracket. This positive sign is as a result of the multiplication sign changing to addition in the exponential region, which is equal to 3 raised to power 0. Another law comes up. which is law of common base, which suggests that the powers also are equal. What is the power on this side? 1 minus 4 is minus 3. Minus 3 minus 2x. Minus 3 minus 2x is the power on this side, which must be equal to the power on this side, which is 0. Why must they be equal to each other? Because their bases are equal. Solve this equation. We have 2x equals 0 plus 3. When you take negative 3 to the other side, crossing the equality sign, it changes to positive. That is why we have this positive there. So we have minus 2x equals 3. 0 plus 3 is 3. Dividing both sides by negative 2, we have negative 2x divided by negative 2 equals 3 divided by negative 2. And finally, we will have x equals negative 3 over 2 as our answer, which could be expressed as negative 1.5 or negative 1.5. In any way you leave it, you are okay. And that is the end of today's work. Before I leave you, according to our usual habit, I want to give you some assignments that you are going to try your hands on, and when we meet, we have the solution of the assignments. Here are the questions I want to leave with you as your assignments. Try your hands on them all. In the next class, we are going to have the solution together. Thank you.